Chapter 3.1 to 3.4, a few more problems. Here's actually 5 more problems that are somewhat represented in the rest of the review, but I thought I should add them just in case you need a little help with them. Number 1, identify any x-intercepts and y-intercepts in the graph respectively. The x-intercepts and y-intercepts, the x-intercepts are where they cross this x-axis. This is the x-axis. The x-intercepts is where the line crosses this. So that right there, that's the x-intercept. And then the y-intercepts are where they cross this line. So, that being said, let's see, we have to figure out where it's crossing. It's crossing right there. So that's the y-intercept. Alright, so then of course, how do we label these? Well, there's a couple different ways. One is that since where this crosses the x-axis, y here is 0. You see it's 0 on y. So since that's crossing at 2, the coordinate pair would be 2, 0. So we could say that the x-intercept is 2 because we automatically know that y is 0 there, so we don't have to put it, but we could do an ordered pair. This is also you'd say this is the x-intercept, you put 2, 0. Notice y is 0 because in ordered pairs the x comes first and then the y. It's always that way. Now we're going to do the y-intercept. Y-intercept being right here, so it's 5, 6, 7, 7. So the y-intercept is 7. Y-intercept 7. But again, we could put x, obviously x is 0 there, right? X is 0 right along here. This is where x is 0. So x is 0, so we'll write it 0, 7. And that's the y-intercept. So that's actually pretty easy, right? Number 2, complete the table, then determine the x-intercept and the y-intercept for the graph of the equation. Okay, so now we're remembering that the x-intercept is where y is 0 and the y-intercept is where x is 0. See, already here we have a 0 right here. Whoops, did it show? Darn it. Here we go again. There we go. Here x is 0, so whatever we put in here, that should be the y-intercept. And we'll have to find out where the x-intercept is. So first thing we do is we plug numbers into this equation. These are all x's, so we're going to plug each one of these in for x and then add 8 to them, and that'll be our y. Okay, so we could do this one at a time. One thing we could do is we could put this equation in the calculator and then use a table from the calculator and just fill in the values. But we can also do it longhand. So we have y equals x plus 8. First thing we'll do is we'll stick in the negative 8. There it is. We'll stick in that negative 8. So y equals negative 8 plus 8. Okay, negative 8 plus 8 is 0, so y equals 0. We'll put in 0 for that. And looks like we have our x-intercept. X-intercept is at negative 8. Okay, so now we're going to stick in negative 4. We've got, again, y equals x plus 8, so y equals a negative 4 plus 8. Y equals 4. Put in 4 there. Okay, we're noticing a tendency. So the top, we have to look and see if there's a pattern in the top, and so we could establish a pattern in the bottom. So it goes negative 8 and it drops, we add 4 to it, add 4 to it, add 4 to it, add 4 to it. See, so for this, looks like there's 4 added here, so this next one's probably going to be 8. This will be 12. This will be 16. Let's see if that happens. Of course, we always got to check at least a few of them, make sure that we're on the right page. Okay, so again, y equals 8 plus x plus 8, so we'll stick in 0. Y equals 0 plus 8. Y is 8, just as we predicted. Okay, and then the next one, y equals 4 plus 8. Y equals 12. Let's see if I can write it in there tiny. No, not too tiny. And the next one's going to be 16, right? Y equals 8 plus 8. Yep, y equals 16. Okay, so it says complete the table, which we've done, and says then determine the x-intercept and the y-intercept for the graph of the equation. Okay, so the x-intercept is where y is 0, so the x-intercept is a negative 8, or negative 8, 0, right? And the y-intercept. The y-intercept is where x is 0, so the y-intercept is 8. So we've got 0, 8. Ta-da! This one is number 3. If possible, find the slope of the line passing through the 2 points. Okay, remember we've got our formula for slope. M equals y2 minus y1 over x2 minus x1. So we're going to decide which one's going to be y2 and y1 and so on. I think might as well go in order here. This will be our x1, y1, and then x2, y2. I know it's big fat stylus here. My other one is charging, but even that one's not that thin. So anyway, okay, we can plug these in. So y2 is 4. So put 4 in for y2. 4 is also y1 minus 4. Well, I see where this is going. And then x2 is negative 5, and x1 is 1, so it's minus 1. So this equals 0 over a negative 6. And so the slope is 0. M equals 0. And the slope is, if we graph this thing, got 1, 2, 3, 4. It's a horizontal line that goes, let me change colors, goes right through 4. It's always going to be 4. Number 4, a line has the given slope m and passes through the first point listed in the table. Complete the table so that each point in the table lies on the line. Okay, which means each point, all these points have to have the same slope. You know, together they end up with the same slope. So we start out, we've got to make a fraction out of our slope, right? Our slope m equals the negative 5. So we'll put negative 5 over 1. That's supposed to be a 5. Negative 5 over 1. Okay, so now I think I'm going to rewrite the thing so it's nice and big, like my stylus. 1, 2, 3, 4. And then underneath we've got 5 here. Okay, so our slope is a negative 5 over 1. Now let's see what our run is here. This is the x's. The difference in the x's looks like it goes up by 1. 1 to 2 is 1. Goes up by 1. Goes up by 1. Okay, so then let's go over here. This is the run. This is the rise. okay, our run is 1. So if we compare these two fractions, we can see that the top is going to be the negative 5. So these need to go up by negative 5, negative 5 and negative 5. So negative 5 plus this, it makes that 0, which gives us our x-intercept, right? Okay, add negative 5, add negative 5. Okay, and then we have a pattern here: 5, add negative 5, add negative 5, add negative 5, and 1, 2, 3, 4. But what if? So that's the solution to the problem. We've completed the table. But what if, for some reason, they didn't have? It wasn't 1. The difference wasn't 1. What if the difference was 1, 3, 5, 7? Okay. What if it was that? And y was 5. Okay. What would these be? How can we figure that? Because then the difference is 2, 2, 2. Right? Okay, but our slope is a negative 5 over 1. Well, 2 is the run, right? This is our run. It's 2. So let's put it down here. 2 is our run. Okay, so now we have to just make an equivalent fraction. 1 times 2 is 2. So we multiply the top times 2 also. We get a negative 10. Okay, so then these, since they're skipping, they're going to be negative 10. Negative 10, that's going to be the difference. Negative 10. See, so this would be negative 10 plus 5 is a negative 5. Negative 10 plus the negative 5 is negative 15. Negative 10 plus this is a negative 25. See, now let's go back to our original one. What if this went, we'll see, just continue the pattern. We have, say, 5, 6, 7. So we can just compare. If we kept going and adding a negative 5 over here, we would get negative 15 here. Let me change color. Negative 15, and add 5, negative 20, and this would be negative 25. Notice that these match up. 5 and negative 15, 5 and negative 15, 7 and negative 25, 7 and negative 25. See, so it works. If your fraction doesn't match what you get out of your table, then make an equivalent fraction for what you do get out of the table. Number 5, use the graph to solve the problem. Find the rate of change in the height of the tree. Okay, so notice up here that the y-axis is about the height, and it's in feet. And the x-axis is about the age of the tree, which is in years. And typically the time is always on this x-axis. Okay, so we've got to find the rate of change in the height of the tree. The rate of change is the slope, so we need to find the slope. We're given 4 well-defined points. This one here, this one, and this one. So, but all we need is 2 of them, because the slope this is a straight line, so the slope should be exactly the same all the way along it. So we'll use our slope formula. Slope formula is m equals y2 minus y1 over x2 minus x1. Alright, and let's figure out what these points are. I don't mind using this one. So that's 0, 0, 0. Okay, so I'll make that 1 point, 0, 0. Okay, and then let's see, I'll use this last one right there. And that one is, the x is 6, and the y is 24. But no matter which 2 points I use, it should work out just fine. So I'll make this my x1, this my y1, this my x2, and then y2. Alright, so then I just plug in the values. Okay, we have 24 minus 0, and my x2 is 6 minus 0. So that gives me 24 over 6 is 4. So my slope is 4. And we could say it's, okay, 4 over 1. But 4 over 1 what? Well, let's go back to our units that are in our table, in our graph. And it's feet per years. So it would be 4 feet per year, or per 1 year. Tree grows 4 feet a year. Let's try it again. We'll use 2 different points. Let's use these middle two. This one and this one. I chose this one and this one because I knew that would be easy, because this one's going to be 0, 0. But it's supposed to work with each of the points, any 2 points, and either one could be our first point or our second point. Okay, so this point is 2, 8, and this point here, the middle point, is 4, 16. That's this one, 4, 16. Okay, so since it doesn't matter which I make which, I'll make this my x1 and this my y1, and this will be my x2 and then my y2. Okay. I'll just plug in the information. I've got my y2 is 8, so 8 minus my y1, which is 16, and that's going to be over 2 minus 4. Now notice my second points are larger than my first points, or my first points are larger than my second points, I should say. So I'm going to get negative numbers, but that's alright. 8 plus a negative 16 is a negative 8. 2 plus a negative 4 is a negative 2. And negative 8 divided by a negative 2 equals 4. Again, we get the same thing. We get 4 feet per year. And that's it. If you can do the problems in each part of the review, the crust will be easy.